Very good evening to everyone. Today we are going to see another topic of theory presentation, which is Introduction to Bridge Engineering. My name is Manas Santosh Kamble. I am from Civil Branch from MIT Academy of Engineering. Coming to the overview, which we are going to see in our today's presentation, is classification and types of bridges, which is the first one. Second is components of bridges. Third one is economical span concept, and fourth one is Afflex, HFL, scour depth. Then fifth one is loads and IRC specifications, and the last one is bridge failures in India. Coming to the introduction of bridge engineering. The definition of bridge engineering can be termed as a bridge is a structure built to span a physical obstacle like a river, valley, road, or railway without closing the path underneath. The objectives of bridge engineering are to ensure structural safety and serviceability under various loading conditions, to select appropriate bridge type and span considering site constraints, material availability, and function is the second objective of our bridge engineering. Coming to the third objective, to design for hydraulic conditions like efflux, scour, and flood levels to avoid failures is our third objective. Coming to the fourth objective, to apply IRC standards and best practices in load estimation and detailing. Coming to classification of bridges, classification of bridges can be in various types like structural form, how they carry loads, example beam, truss, arc, cantilever, suspension, cable state. These are all types of structural form which we have classified just now. Coming to the next classification of bridges, in terms of material, it is what they are made of. For example, timber, steel, concrete, stone, and etc. Coming to the function, the classification, what they are used for, example highway, railway, pedestrian, and etc. Coming to the span length, the classification is also done in span length, which is also important, like how long they are, example short, medium, long span. Then deck position is also important, like where the roadway is related to the structure, example deck, through, and etc. Mobility, coming to the mobility part, whether they move, movable, or stay fixed. We have seen various types of trees which are movable in foreign countries, but they are not currently available or used in India. Coming to the classification of bridges in structural form, as we can see in the images, I have mentioned six types of bridges or six classification of bridges, that is beam bridge, truss bridge, tied arc bridge, suspension bridge, arc bridge, and cable stayed bridge. These are most important or most prior classification of bridges in structural form. The beam has a simple horizontal support. A truss is a network of triangles for efficient load distribution. Arc is a curved structure carrying load in compression. Then cantilever is a projection arms at one end. Suspension is deck hung from cables. Cable stayed is deck directly connected to towers by cables. These are all types of classification of bridges in structural form. All of these are variously used in various applications, like truss bridge we can see railway carrying through it. Cable stayed bridge is very highly known, that is Bandra Worli Sea Link. Then beam bridge also we can see near Alandi. There are various types of bridges we see in our day-to-day life. Coming to the main components of a bridge, it is divided into superstructure and substructure. In the image, we can see deck slab, girders, and trusses. In substructure, we can see piers and abutments. Then we can see bearings, approach roads, expansion joints, parapet, and railings. These are all various components which we see in bridges. Also, apart from the mentioned components, we can see in image approach slab, a bridge deck, low steel, vertical abutment, then pier. Also, we can see the pile caps and spread footer. Also, sloping abutment in the image, which are also components of bridge. Then coming to the concept of economical span. What is economical span? We will first see that it is the optimal length of a single span that results in the lowest overall cost for the entire bridge. The trade-off, we can see shorter span, lower cost per span for superstructure, but higher total cost due to more piers and foundation. In longer span, we have higher cost per span for the superstructure, but lower total cost due to fewer piers and foundation. Key factors which influence economical span is cost of superstructure materials and construction. The material and the type of construction also vary as per the places or the areas or the regions where we do the construction of a bridge. Then cost of substructure like piers, foundation also vary as per the area. Then foundation condition and soil type also varies as per the region. Like in Konkan we can see various another type of soil compared to Pune. Also topography and site condition, site constraints can be there, like in Shimla or highly hilly regions like Mahabaleshwar we can see bridge or bridge built on a higher latitude, but in Pune we can see in a normal topography. It is the change in all of this economical span. Then coming to the goal, why concept of economical span is very important. It balances the cost of superstructure and substructure to achieve the most cost effective design for a given length of beam or given total length. Then coming to the point efflux, what efflux is and what are the key points about efflux. It is a localized effect occurring upstream of the bridge. The effect diminishes as you move further upstream. The magnitude of efflux depends on several factors, including the degree of obstruction caused by the bridge, that is number of piers and sizes of number and sizes of piers, reducing waterway opening. We can also see a factor like the velocity of flow, the shape of the bridge piers and abutments, the geometry of river channel. These are all four types of factors which are affecting the magnitude of efflux. Then coming to efflux is a critical consideration in bridge design because it can reduce the freeboard, that is vertical clearance between the water surface and bridge deck, potentially leading being overtopped during floods. It also increase the flood risk in upstream areas, potentially inundating land and properly uh, that would otherwise be safe. Then influence the sedimentation patterns upstream and downstream of bridge, affect the hydraulic forces acting on the bridge structure itself. This is all what we can see from the applets. Coming to image, now we can see the image part. Just a second. Coming to the image part, now we can see a image where a bridge duct is there, column is there, a normal water profile we can see. The portion like bridge afflux, that is DH, is a type of afflux which I am talking about. We, as explained from the theoretical point, we can understand what bridge afflux is. Uh, Coming to the next topic, that is high flood level. High flood level refers to the maximum level of water has been recorded or is estimated to occur at bridge site during a severe flood event. It represents the highest watermark reached by flood waters in the past historical HFL, that is high flood level, or the predicted peak water level for a design flood of a specific return period. Key aspects of high flood level are maximum water elevation. It's the highest elevation the water surface is expected to reach during a flood. Then historical data and prediction determined by analyzing past flood records, hydrological records, that is rainfall and runoff, and employing statistical methods and hydraulic modeling. Coming to the design flood, often associated with specific design flood event, example 50-year flood, 100-year flood, which is a flood magnitude with a defined probability of occurrence in any given area. Now we can see an image of high flood level. Generally we can't see a bridge, but these types of flood level can be seen in areas like 6 meter up to 8 meters, 5 meters. This type of bar measuring scale on a type of column we can see in various areas of bridge is provided. Generally, it is very useful because in floody areas, the flood level can be identified through these measuring scales only. Coming to our next point, that is scour depth. Scour depth refers to the depth of erosion of riverbed material like sand, silt, and gravel around bridge piers, abutments, and other obstructions caused by flow of water. It is the vertical distance from the original bed level down to the lowest point of the eroded area. Key concepts of scour depth are erosion by flow. The force of flowing water creates vortices and increased shear strength or shear stress around bridge elements which can dislodge and carry away bed material. Localized phenomenon can be score is typically most severe immediately adjacent to bridge foundations. Also, it is a time dependent. Scour can develop rapidly during flood events and may partially refill during lower flows. But long term scour can also occur due to changes in river morphology. Critical for stability is another key concept, that is excessive scour can determine the foundation of bridge leading to a structural instability and even collapse. Scour depth is also a very important term in bridge engineering due to which we can understand the depth of erosion during the flood areas or the flood events. It is very useful as it refers to the depth of erosion of riverbed material as we discussed like sand, silt and gravel. Coming to our next point, I can see you the image of tell you the image regarding the scour depth. Now we can see pier is there, water surface is there, a downflow is there, and wake vortex is there. And besides under bottom of the or and the downside of the wake vortex, we can see the scour, which I am trying to explain you through this theoretical part. Scour looks like this apart from looking the image. Coming to our next point, which is loads on bridges. There are various loads on bridges. Coming to the first load, that is dead loads. The bridge self or self weight or own weight is known as the dead load. Live load is weight of moving traffic like vehicles, pedestrian, trains temporary as I shown in the diagram. Then impact load is extra force from moving traffic's vibration. Then fourth load is environmental load, which is the force from wind, earthquakes, temperature changes, water, snow and ice and etc. Other loads can be forces from braking, acceleration, curves, collisions and during construction. Engineers also consider combinations of these loads to ensure bridge is strong and stable under all expected conditions. Coming to our next part, that is IRC load specification. IRC has loads and stresses. Standard loading types can be IRC class A supports general traffic, IRC class B supports temporary structures, IRC class AA supports heavy industrial or defense vehicles, IRC class 70R supports tracked wheel vehicles. And coming to the image, now we can see various types of loads IRC has given from the vehicle. We can identify, as you can see in the load, it is axle loads in ton given on the x-axis of the image. We can see from the load coming from the axles of the vehicle. Coming to the bridge failures in India, there are various bridge failures in India. Common causes of bridge failures are foundation scour, poor maintenance, overloading, design or construction flaws, then natural disasters like floods, earthquakes. Some notable examples of bridge failures in India are Kolkata Vivekanand flyover collapse 2016. The image of Kolkata flyover collapse 2016 is shown on the right side of our slide. Coming to Morbi suspension bridge failure 2022 is I can show just a second. The Morbi suspension bridge failure 2022 can be seen in the image I shown. Coming to our third, that is Siliguri coronation bridge issues can be seen in the last image. Then the lessons learned from the bridge failures in India are importance of inspection should be there, retrofitting should be there, and disaster preparedness also should be there. If we follow these lessons that we have learned, then the bridge failures in India can minimize or also can be completely stopped. Coming to the point of conclusion, what we have done throughout this presentation, I have noted some key takeaways for you. First is bridges are critical infrastructure, linking communities and enabling transport. Second is classification and types of bridges, guide selection based on site, purpose and materials. Proper understanding of components ensures efficient planning and maintenance. Concepts like economical span, efflux, HFL, and scour depth are crucial for hydraulic and structural safety. Then loads and IRC specifications provide standardized design safety guidelines. And the last point is failures in India underline the need for better design, inspection and maintenance system. My friends, this is all for our today's presentation from the TRE, that is Introduction to Bridge Engineering, in which we have learned all the key concepts of bridge engineering. And now I may take a leave from my side. If you have any question and answers, you can comment in comment box. Thank you.